I'm Nick Pilgram,
And I'm Ian Powell.
and here's our project of an automated blind system.
Here is the control panel for our automated blind system. Here's the brightness level control, and here's the real-time output of the brightness level on the photoresistor array. As you change the brightness level, you can see that the blinds will adjust, and you can see the real-time change right there. Keep moving it back down. Right here, this is the output of our dark activated circuit, so it's steady right now because it's light out. Here's the output voltage of our photoresistor array, and this is our sensor to show if the blinds are closed. We've also included manual control so that you can open and or close the blinds as you desire. Now moving over to the circuit, you can see the blinds actually move as we adjust the brightness level here. It also moves if we make it darker, and it'll also change as we add light to the blinds and then adjust back because of that. The coolest part here we have is our automated system, so that when it gets dark out, you want your blinds to close. So we cover up the photoresistor here, and it closes, and then it works again. See dark, and it'll stop, and that signals it to stop, that it's closed. And so everything should work. It's automated blind system.
This is the central part of our circuit. It's a large voltage divider. We have 5 volts going in and then a bunch of photoresistors. This green wire is our output voltage, and then we have ground. Going over to the diagram, it's just many cadmium sulfide photoresistors in series, so that when the light level changes, we'll get a variable V out right before the 1000K resistor there. And depending on the V out, we will change the position of the blinds here.
Alright, here's our dark activated circuit. We have our photoresistor here sensing the darkness levels. We have our op amp right there, potentiometer which adjusts the sensitivity, and we have our output coming off right here, off the transistor there. Moving over to the diagram, how this thing works is we have our photoresistor here, and there's a voltage divider essentially coming off of it. So as the light levels change on the photoresistor, the voltage out will change, and that goes into the op amp, which compares it to the reading off of the pot. And when it becomes dark enough, the op amp signals the transistor to open and send a current through this resistor here, which then activates our voltage divider, where we can get our voltage out reading, so that there only is a voltage spike when it becomes dark.
Here's our lab view code. We initialize by opening our lab jack and reading in the voltage from our voltage divider here. It's channel 0. We create a real-time plot by initializing our time and comparing that with our voltage here, bundling it into an XY graph. Now, here, if we want to use manual control, we go into this case structure, so that if we choose the close button, we close. If we choose the open button, we open. And if neither are clicked, then we automatically break. So if we don't click the manual control button, we go into this case structure. Now here, this voltage 2 is read in from analog input number 1, which is the dark activated circuit's input. So if the voltage 2 is less than 2, aka the dark activated circuit isn't activated, then we go here to this case structure. So in that case, it would be true. And we have our automated blinds code here, so that the brightness level of this voltage up here from the analog input 0, we do some comparisons and basically just make sure that it reaches the voltage that we need it to. So here we have our opening, our closing, and our breaking when we've achieved a voltage near the threshold. So if we move to our other case structure, where we have our dark activation, then here we also have our ultrasonic sensor, and we say, okay, we close the blinds until our ultrasonic sensor reads false here, so that it reaches our threshold position. And that is our LabVIEW code. We learned that everything is a voltage divider.
It's amazing how many circuits rely on voltage dividers to get outputs and comparisons within them.